Welcome to our online lesson series. This is online lesson number 3, and this time we'll be solving linear equations with fractions. And if you remember from last week, we were solving simple linear equations. So this will be no different. We'll still be using the same skills, but these ones will actually have fractions inside of them. Let's start with the learning objectives. So this lesson we're going to learn how to solve linear equations that contain fractions, and we're also going to learn some nifty tricks to help us later on. But before we begin, what if I were to ask you to solve for x if you were given the equation below? Some of you may say, well, you told me last week that x is no different than just a placeholder. So I could think of this thing as some box over 21, some number over 21 equals 4 over 3. And after some thinking, you could probably guess, well, these are just equivalent fractions. If I can try to figure out what number would go on top to make these equivalent fractions, then I've solved the problem. Another may say, well, I can also split this up, or I can represent this as 1 over 21x equals 4 over 3. And then you'd continue on with your algebra. One other may say, well, I think I remember that you can multiply opposites and end up with something like this. The point is that no matter which way you choose, whether it's this way, or this way, is that there's always more than one way to solve a problem. So let's get into our examples. What if I were to give you this one instead? If we were to solve for x in the equation x over 21 minus 4 over 3 equals 5x over 7. Now there's a lot of fractions going on here. And before we actually begin, I want to say something about the fractions. Is when you start seeing fractions inside of an equation, we want to keep the fractions all the way through the actual solution. And we do this for accuracy, to make sure that, if we were to convert to decimals, sometimes we have too many decimal places and we lose some accuracy of what the solution is. And second reason is fractions are actually easier to work with than the decimals. So let's recall last lesson. Last lesson we learned how to solve linear equations like this one, where there was no fractions, and the goal was, remember, to get x all by itself. So in this particular problem, we would try to get the x's to one side of the equation and the numbers to the other. So let's just decide to move this single x to the right-hand side. And what we'd end up with is minus 4 over here and 5x minus x. And just remember, I knew it was a minus x because it was a positive x on this side. And then we would carry on. We'd keep the minus 4. And this 5x minus x would become 4x. And we would divide both sides by 4. And we would end up with x equals minus 1. Well, what if we were to have fractions instead of the whole numbers in the equation? Big whoop. It actually makes no difference whatsoever, because we're still going to isolate for x, and that is to say that we're trying to get x all by itself on one side of the equation, and we're going to get the numbers on the other side of the equation. So, same as last one, we were moving that x on the left-hand side to the right side so that we could get all the x's by themselves. So let's do the same with this one. So we'll get that term to the other side. It's a positive on this side, so it'll become a negative on the other. So we've got minus 1 over 21x. And just to point out, on the last slide, this x on the left just really just represents a whole x, one x. This one on the right-hand side represents 5 x's. Fractions are no different in that the 5 over 7 times x literally just means 5/7 of an x, and the 1 over 21x is just 1/21 of an x. But we can still do the algebra on this. We've learned how to add and subtract fractions in class. So on the right-hand side, I'm just going to do a quick calculation here. Oh, this is minus 1 over 21. So I'm able to do this by finding a common denominator, and that would be 21. So we multiply this fraction on the left, top and bottom, by 3. So we end up with 15 over 21 minus 1 over 21. And what we have after that is 14 over 21. And we can even simplify that a little bit further because 7 goes into 14 and 21. So we can simplify that to 2/3. Okay, so back to our equation. If we've got 5/7 of an x and we subtract 1/21 of an x, we actually end up with 2/3 of an x. So like I said, it's no different than before, it's just now we're adding and subtracting fractions. So we're left with 2/3 x. Perfect. So now what? We still have fractions in here, but don't let those confuse you. This 2 over 3x literally just means 2 over 3 times x. So how do we get rid of a multiply attached to the x? Well, what did we do here? This represents 4 times x. And in order to get rid of it, we had to divide by 4. And what we do to one side of the equation, we have to do to the other. So what we're trying to do here is we're going to actually divide this side by 2 over 3. And we're also going to divide the left side by 2 over 3. So let's write that out in full. We've got negative 4 over 3 divided by 2 over 3 equals x. And again, we covered division in class. So what we can do is we can flip the division, change the division to a times and flip that second fraction. So the 2 over 3 becomes 3 over 2, and that will be the exact same question. So now we're stuck with a multiply on the left-hand side. We're almost there. And remember, with a multiply, we just let it fly. We multiply tops, multiply bottoms, and what we end up with is negative 12 on top and 6 on the bottom. And we're almost there. We can simplify this even further, and we can confidently say that x equals negative 2. The nice part about this is we can actually go back and check to see whether our answer is right. And we can do it by, of course, substituting x equals negative 2 into the left-hand side of the equation and the right-hand side of the equation and seeing if they're actually equal. I'm not going to do it here, but that's a very quick way at the end of a test to check to see whether your answer is right. But in general, 1 over 21x would actually be represented as x over 21. That's a more likely way that we'd see it represented. And another example here, 5 over 7x would generally be represented as 5x over 7. And you may be thinking right now, why? How does that even work? So for those of you who are actually interested, this is how it works, is 1 over 21x really is 1 over 21 times x. But x we could also write as x over 1. And if we were to actually multiply this through, we'd have x over 21. So these are no different whatsoever. So what we would do is, in general, we'd want it in this form on the left, but it would likely be represented in a question as something that looks like the one on the right. And depending on the actual question, one may be more advantageous than the other. So for the example we just saw, it was actually more advantageous to keep it the way that it was. But in other cases, which we'll see, it may actually be more advantageous to keep it in the form to the right. But they're both exactly the same. So if we go back to our first example, and we were to solve for x in this particular equation, we could rewrite it to help us see it a little bit better. We could rewrite it as 1 over 21x minus 4 over 3 equals 5 over 7x. But wait a minute, we actually just solved this one. And these actually represent the exact same question. So we already know how to solve this one. We end up with x equals -2. But just to reiterate, these are exactly the same things. Well, you might want to take a break. And you're doing great. And while we're talking about doing great, let's just take a minute to observe this color yellow. I'm thinking that's probably mustard yellow. I don't know what you think, but I think that's the color of mustard. Okay, moving on. For our second example, we're going to solve for x in the equation 4x plus 1 over 7 minus 5 equals 2x plus 3 over 9. So this is a little bit different than the last one, because the last one we would have only had something like 4x over 7, not 4x plus 1 all over 7. And some of you may be seeing this and panicking, but let me just tell you right now, step 1, don't panic, and always do what you can. Step 2, hold your horses, and remember what you do know. And in Brooke's case, you can just hold your ducks. Before we begin this example, let's review what we already know about fractions. Let's say we were going to add 4 over 7 plus 1 over 7. We know this from class that when we're adding and subtracting fractions, what we really care about is that they have a common denominator first. That is to say the bottom number is the same. If they're not, we change it to be such. But in this case, it's already a common denominator, which is 7. So if we're to add these two fractions together, we just simply add the numerators together, and we put it all over 7. That is to say 4 plus 1 over 7. And we would say, oh, this equals 5 over 7. And that'd be true. So let's take it a step further. How would we add 4x over 7 plus 1 over 7? There is absolutely no difference whatsoever. We would add it the same way. The denominators are the same. These are just two fractions, and one just happens to have a letter. They've both got the denominator of 7, and that means that we just add the numerators.